After arithmetic progression, we have geometric progression. And just for comparison, I'll be writing both formulas. Term number un or tn was given by a plus n minus 1 into d. In case of GP, term number would be given by a r raised to power n minus 1. On the other side, sum of term was given by n by 2 into 2a plus n minus 1 into d, and sum of term would be given by a into 1 minus r raised to power n over 1 minus r, or I'm writing two formulas, they're same, r raised to power n minus 1 over r minus 1. I'll explain what r and a is. And we have one more formula, last one for this, that is sum up to infinity is a over 1 minus r with a condition that r should be in between 1 and minus 1. So you've already seen what a, d and n is in AP, and in GP a is the same first term, r is the common ratio. In AP, d was the common difference, like 3, 5, 7, 9, 11. D in this case was 2, A in this case is 3, common difference was 2. Now we have R. R is common ratio, that is term n plus 1 divided by term n, and D was term n plus 1 minus term n. D was the difference, this is the division, the ratio. For example, we have 2, 4, 8, 16. So we choose any of the two. R is equals to 8 by 4, that is 2. Or we can choose these two. R is equals to 16 by 8, that is 2. Which means every successive term is being multiplied by 2. So that is R. N is same. Term number A is given. So for example, we are given with the sequence, one of which is already there, 2, 4, 6, 2, 4, 8, 16, 32 and so on. And let's say the examiner says find the sum of terms. So we'll write 1 minus r raised to power n over 1 minus r. And suppose we have these 5 terms, so we can cross check sum of first 5 terms. A is 2 in this case, 1 minus r is again 2 in this case, and when n is 5 over 1 minus 2. So now we use the calculator and just plug those values in. 2 into 1 minus 2 raised to the power 5, and in denominator we have 1 minus 2, and I'm getting 62. And what do we get when we add these all? 2, 4, 8, 16 and 32, again 62. But we do need these formulas because we may have many of these terms. For example, the sequence stays the same and examiner tells you to find sum of the first 255 terms. So all you have to do is just plug in the values. A is 2, 1 minus r is 2 raised to the power 255 and divided by 1 minus 2. So I'm getting 1.157 into 10 raised to the power 77. And about the third formula, this is a over 1 minus r to find the sum up to infinity, but the condition is r has to be between 1 and minus 1. And when r is less than 1, that would mean the second term or the successive term is actually decreasing. For example, we have 100, 50, 25, 12.5. You see, I'm dividing all these terms with 2. So r is equals to 1 by 2 in this case. Now we can find the sum up to infinity because we keep on moving, it will approach 0. So that is 1 a over 1 minus r all the time. So this is a, that is the first term, 1 minus 1 by 2. We simplify, we get 200. So sum up to infinity, when you keep on adding these terms, they're converging, you get 200. Any confusion till now? So if we have to find the general formula for any sequence, let it be this one. We had a r raised to power n minus 1. So a is the first term in this case, that is 100. R is the common ratio, that is 1 by 2, and n minus 1. So this is it. This is your formula. And if the examiner tells you to like find the third term, which is right in front of us, which is 25, so we can use the formula, plug in 3 and see what do we get. So 3 minus 2 is 2. So 1 over 2 square is 100 times 1 by 4, 4 1 times 4, 25. So that's a cross check that our formula is correct.